Hello students, good morning. Today I am going to discuss idea of sets. In this chapter we already completed 4 sessions. So this is the 5th session of the chapter idea of sets. In the previous class we already discussed some types of the sets, right? In 4th session we already discussed some types of the sets. In that first one, finite set. Finite set means if any set has the countable number of elements, then that set is called as a finite set. It means the set which existing the definite number of, or which consisting the definite number of the elements in the particular set. And every finite set has some definite elements only, either 1 element or 2 elements or 10 elements, 20 elements. All the elements should be countable. So that type of the sets are called as a finite set. Okay. And next one, infinite set. Infinite set means if any set consisting infinite number of or uncountable number of elements, then that set is called as a infinite set. Example, the collection of the natural numbers, or collection of the whole numbers, or collection of the integers, because we can write infinite number of whole numbers, integers and natural numbers. So these are the 3 best examples for infinite set. And next one, empty set. Empty set means a set which do not have any element. If a set which do not have any element means, then that type of the set is called as a empty set. Empty set. That empty set is also called as a null set or void set. Null set or void set, and these sets are represented by the symbol of empty braces, or just we are indicating with a symbol like this. So these two are the symbolical representation of the empty set. Next, come to the next concept, that is cardinal number. So cardinal number means the number of elements which are existing in one particular set. It means if a set A has 4 elements, means then their cardinal value or cardinality is 4. Clear? If a set A has 4 elements, this hand has 5 fingers, no? So the cardinality of this set is 5, like this. If any set has 1, 2, 3, 4, like this, if I am taking A as a set and it consisting 4 elements, then the cardinal number of set A is 4. Also called it as a cardinality, and it is represented by n of A, which is equal to 4, because the set A consisting 4 elements. Okay, and we discussed some basic properties that is related to cardinal numbers. The first one is every finite set has the definite cardinal number, right? Second one, while we are writing the cardinal numbers, we need to represent the finite set in the tabular form or roster method, because in some conditions or in some statements, some letters or numbers, it may be repeats. That type of the repeated numbers we are ignoring or neglecting, and we are considering it as a one time only, and consider the whole set as a one group, then only we will get the total number of the elements. For example, the letters of the word apple. What is the cardinality of this word? Here P repeats 2 times, means first I need to write the word in tabular form or roster method, APLE. So once I write the given word in tabular form or roster method, then I can easily write the cardinality number. If I am considering this is a set of the words, this is the A is a set of the letters of the word apple, then the cardinal number of set A is 4. And third property is, for infinite sets we cannot write any cardinality number, because for every infinite set the cardinal number is infinity. This is the infinity symbol. And next one, come to the fourth property, that is every empty set, the cardinal number of empty set is equal to 0. It means the empty set do not have any element, which do not consisting any elements inside the set. And one more, equal set and equivalent set. Equivalent set means if two sets having equal number of elements, then that 2 sets are called as a equivalent set, whereas equal set means if any two sets are having equal number of elements, and all the elements which are existing in that two sets, no, they are same, then that two sets are called as the equal sets. We already discussed these things in the previous class. Now I am going to discuss the next type, that is the universal set. Universal set. And these universal set represented by the symbol U. These universal set represented by the symbol U. So what is the definition of universal set? Universal set is a set which containing all the elements of the objects of other sets including its own element. It is usually denoted by U. It means it is a whole group. If I am taking two or more subsets, while I am considering all these three sets as a one set, means that one set indicates it is a universal set. Can I take one example? Universe. Universe is one of the universal set. Why? Because that universe has the group of the stars, group of the planets, group of the satellites, group of the galaxies, group of the dusty cloud particles, right? So these all groups belonging to the one group, that is universe. Clear? For example, universe. Universe is a group, means that universe consisting stars, galaxies, right, satellites, planets, some asteroids, next one moon, sun, some sub-satellites. So all that are belongings to the one group which are considering in the same group, that is the universal set. It means if two or more sets having same kind of the properties belongings to the one set or one particular statement or one particular condition, that satisfying the one particular condition, means that type of the sets are called as a universal set. Okay, I will take one more example. A is a set of vowels of English alphabetical letters. So what are the vowels which are existing in English alphabetical letters? A, E, I, O, U. These are the 5 vowels in English alphabets. Set B. B is a set of consonants of English alphabetical letters. If I am taking C as a universal set, means set 1, set A and set B, all the elements of set A and all the elements of set B are belonging in the set C. It means English alphabetical letters. So here C is nothing but the universal set. And A and B are the set A and set B are the subsets. A and B are the subsets of set C. Clear? Because English alphabetical letters means we write from A to Z, right? So consonants means other than these 5 letters, no? B, next one C, D, E is a vowel, next F. So other than these 5 letters, there are totally 21 consonants are there in English alphabets and 5 vowels are there. When these two consonants and vowels belongings to the same group, that is English alphabetical group, then this group or this set is called as a universal set. Clear? So it is a one set which satisfying all the subsets. The next method or in next type, while discussing about the subsets, what is the exact meaning of subset and how we can form the subset. Okay, let's take one more example. If set A is students of class 8th A, A is a set, it indicates the students which are existing in 8th A class, 8th A section. Here A is a one of the section. Okay. Next, set B is a students of the class 8th B. Set C is a students of the class 8th C. Now set D is a students of class 8th. Just observe these 4 statements. In first statement, what they gave? Students of class 8th A. In second statement, students of class 8th B. In third statement, students of the class 8th C. So these are the 3 sections of one particular class, that is 8th. It means all these 3 sets, set A, set B, set C, is belongings to the one set, that is the students of class 8th. These all students, what they are existing in these 3 sets? No. In set A, set B, set 3. All these students are belongings to the same class, that is 8th class. So these type of the sets are called as a universal set. Here the universal set is showing the same type of the property or same kind of the conditions that satisfying all these 3 subsets A, B, C. Okay. So this is the first type of the set, universal. Next type one is subsets. Okay, see the next type, that is subset. So in universal set I already told the word subset. Now what is the exact meaning of subset? How we are going to be consider that subset? If A and B are 2 sets such that every element of A is an element of B also. Every element of set A is a element of B also. Then A is a subset of B. A is a subset of B. It means if I am taking any 2 sets, here I will take one example. With the help of that example, I will show that how we can form the subset and what is the exact definition of subset. A is a set of 1, 2, 3. Set A has 3 elements. Set A has 3 elements, and what are the 3 elements here? 1, 2, 3. And set B has 1, 2, 3, 4. The elements of set A is 1, 2, 3. The elements of set B is 1, 2, 3, 4. Right? Here, if we are taking any 2 sets, the elements of one set is already belonging in the another set, means then first set is a subset of the second set. Clear? No. Listen here. What are the elements of A here? 1 is the element which belongs to A. 1 is the element which belongs to the set A. And 2 is the element which belongs to set A. 3 is the element which belongs to set A. And all these 3 elements are belongings to the one more set, that is B. Right? 1 and 1, 2 and 2, 3 and 3. So all these 3, the 3 elements of set A is already there in set B. Expect this 4. So then A is a subset of B. A is a subset of B, and this is the symbol we are using to represent subsets. The symbol represent A is a subset of B. Right? A is a subset of B. So how you can define the subset? If A and B are 2 sets, the every element of set A is belongings to the elements of set B, means then set A is a subset of B. Set A is a subset of B. Okay. Listen here. One more element is there. What about this element? 4 is extra is there, no? Here one more extra element is there. So 1, 2, 3. These 3 elements are already there in set A, but 4 belongs in only set B, but it is not belongs in set A. Then B is not a subset of, B is not a subset of, this is a subset symbol. If any element which not existing in set A means the three elements 1, 2, 3, all these three elements are already belonging in set A, but the one element that is 4 which is existing in set B but it is not existing in set A, then set B is not subset of A. So this is the symbol we are using to represent non-subset. Just cross the symbol. It indicates set B is not a subset of A. Here, how you can read this one? A is a subset of B and B is not a subset of A. B is not a subset of A. Next one. Take one more example. P is a set of 1, 2, 5 and Q is a subset of 2, 5, 1. Check whether P is subset of Q or Q is subset of P. What are the elements of P here? 1, 2, 5 and the elements of set Q is 2, 5, 1. So 1 is belonging in set P, 2 is belonging in set P and 5 is also belongs to set P. All these three elements belonging in another set that is Q also. Right? So these three elements are already existing in Q also. It means it indicates that P is a subset of Q. P is a subset of Q. Why? Because all the elements of set P is existing in set Q also, either in the systematical order or in the irregular systematical order also. We are not consider here the order of the elements. Okay? So P is a subset of Q. For considering Q first time, Q is a set. And what are the elements of set Q here? 2, 5, 6. Just take the reverse of Q and P means. In first condition we are considering, we are comparing first set P to set Q. Yes, set P is obviously the subset of Q. Now take the reverse order. Whether the elements of set Q is existing in set P or not. What are the elements? 2. 2 is already there in P. 5 is there in P. So 1 is also there in set P. So it means P is a subset of Q and Q is a subset of P. If these two conditions, if P is a subset of Q and Q is a subset of P means, if these two conditions satisfied means it indicates that P is equal to Q. P is equal to Q. We already discussed in the previous classes, equal set means if two sets are having equal number of elements, along with that the same elements means the set P and set Q. What is the cardinality number of set P here? The cardinality number of set P is n of P is equal to 3 and the cardinality number of set Q is also 3. So both set P and set Q has equal number of elements 3 and 3. And all the elements which are existing in these two sets are equal only. 1, 2, 5. Here also 1, 2, 5. So these type of the sets are called as a equal set. If these two conditions, if P is a subset of Q and Q is a subset of P, then the two sets are equal sets. Okay. Next, some properties are there in subsets. The first property is every set itself is a subset. The first property, every set is it's one of the subset. And second property is every null set or empty sets is a subset of any set. You can take any set, for any set, empty set or null set is a one of the subset. Okay. Find the subsets of set A. Find the subsets of set A, and the elements of set A is A and B. So how you can write the subsets of the particular set? So what are the subsets of set A here? It has two properties. Now first one, every set is a subset of itself, and second one, every set has empty set as a one of the subset, or empty set is a one of the subset for every set. So required subsets are the first one A. A is one of the subset, and next B is the second subset. Third one AB is the subset, and empty set is also one of the subset. So how many subsets we are getting here? 1, 2, 3, 4. So totally 4 subsets were formed by using these two elements. Next, take one more example. Find the subsets of set B, and set B elements are 2, 8, 5. Form the subsets by using these 3 elements. So subsets are the first subset is, whenever you are going to be write the subset, first take single elements or single digits, next 2 elements, next 3 elements, like that. Then you can easily able to write all the existing subsets in the particular set. So first one 2, next 8 is the one of the subset, next 5 is the one of the subset. So single digit sets these are. Now take 2 digit sets, 2 and 8 one set, 8 and 5 another set, next 5 and 2 are 2 and 5, both are same only. Okay, so how many sets we have here? 1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6. Next one 2, 8, 5. So every set is a subset of itself only, means here we are considering the same set as its subset, and one more property or one more subset is 0 set. So these are the 8 subsets, 1, 2, 3, 4, 5, 6, 7, 8. 8 subset we are forming with the help of the 3 elements. Okay, next one. So the next concept is number of subsets. This is the important concept. How we can calculate the number of subsets of a particular set? If a set has 2 elements, means how many subsets we can form. If a set has 3 elements, means how many subsets we can form from that set. If set has 10 elements, then how many subsets we can form with the help of that set. It has one particular formula, that is, the formula is number of subsets is calculated by using the formula 2 raised to n of a, 2 raised to n of a. Here n of a, what it indicates n of a? The cardinality number of set A, or we can also write it as 2 raised to number of elements in the set, Can we check, just verify whether the calculation part and what we are rating, the number of subsets is equal or not. Just apply the formula. What is that formula? 2 raised to n of a, right? So n of a is nothing but the number of elements which are existing in that particular given set. So n of 2 raised to, how many elements are there in set A here? 2 elements. So 2 raised to 2 is nothing but 4. Just multiply 2 times. 2 raised to 2 is nothing but you need to multiply that 2 times. So 2 into 2 is 4. 2 into 2 is 4. How many subsets we are getting here? 1, 2, 3, 4. So by arithmetical calculation and by the formation of the sets, both are verified here. Okay, check it for second question also. What is that formula? 2 raised to n. 2 raised to, how many elements we are having in set B here? 1, 2, 3. 3 elements, right? So if 3 elements are there, means need to multiply 2 3 times. 3 cube means it indicates you need to multiply the 2 3 times. So 2 2s are 4, 4 2s are 8. 8 is the total. We are getting 8 subsets. If any set has 3 elements, means we are getting 8 subsets. Just check whether we are getting 8 subsets from the set B or not. 1, 2, 3, 4, 5, 6, 7 and 8. 8 subsets are there, no? Similarly, if 4 subsets are there means, or if 4 elements are there means 2 raised to 4. 2 raised to 4 is nothing but 16 subsets we will get. If 5 elements are there means, in one set, if 5 elements are there means, we are getting 32 subsets. If set 6 elements are there means 2 raised to 6 means 64 elements, or 64 subsets we are getting. If a set has 4 elements, then with help of that 4 elements we will form 16 subsets. If set has 5 elements, with the help of that 5 elements we can form 32 subsets. Next one, if set A or B, whatever it may be, if any particular set has 6 elements, then from that 6 elements we can form 64 subsets. Okay, so this is the formula we are using to calculate the number of subsets existing in particular set. Next one, see the next method, that is proper subset. Proper subset. So these are the some important types of the sets, and all these types will be repeat in your higher classes also. Okay, so the next method, next step type is proper subset. Proper subset. So how you can define the proper subset? Just see the statement of the proper subset. Any subset A is said to be proper subset of B if there is at least one element of B which does not belonging to set A. That is, A is a subset of B. A is a subset of B, but A is not equal to B. A is not equal to B, and the proper sets are represented with the help of the symbol. This is the symbol we are using to represent the proper subsets. Okay, let's take one example. With the help of this example, we will understand what is the exact meaning of the proper subset. A is a set of the elements 1 and 5, and B is a set of the elements 1, 6, 5. Just observe the elements of set A and set B. What are the elements which are existing in set A here? 1 and 5. Now what are the elements which are existing in set B? 1, 6, 5. Right? So A is a subset of B here. Why? Because the elements 1 and 5, it is already there in set B. Therefore, set A is a subset of B. We already discussed, no? If any set has the elements of another set, means that first set is a subset of second one, right? So like that, A has 2 elements 1 and 5, and the 2 same elements, it is already existing in set B. Then A is a one of the subset of B. A is a one of the subset of set B. And in set B we have one more extra element, that is 6, right? Therefore B is not a subset of A. B is not a subset of B. B is not subset of A. From these two sets, set A which is not equal to set B. Set A which is not equal to set B, because the elements of set A 1 and 5, whereas the elements of set B is 1, 6, 5. It has one extra element, that is 6. So see the once again the statement of the proper subset. Any subset A is said to be proper subset of B if there is at least one element. Here at least one element. It may be more than one also, but at least one element should be not belongs to the another set. It means here set A has 2 elements and set B has 3 elements. In that, the 6th element which is not belonging to the set A, it indicates that set A is a proper subset of B. Set A is a proper subset of B. Okay. So this is the definition and symbol related to the proper subset. Clear concept? Take one more example. If A is a set of B, C. And B is a set of A, B, C and D. Just identify, just observe the elements which are existing in set A and B. A existing in both two sets, B and B which is existing in both two sets, C and C. So all these three elements are existing in set B means A is the one of the subset of B. A is a subset of B, but at least one element. So D is at least one element which is not belonging to A, but it belongs to only B. So D is belongs to B, but D is not belongs in the set A. In these types, set A is a proper subset of B. A is a proper subset of B. Okay. Next one is superset. Superset. See the statement of this superset. Superset. How you can define the superset, or what are the conditions which have superset? If A is a subset of B, so first condition, what is that? A is a subset of B. A is a subset of B, then B is called as a superset of A. B is called as a superset of A. Superset of A, and superset is denoting by this symbol, just the reverse of the subset. We are representing subset with the help of this symbol. This is a subset symbol, and superset symbol is reverse of the subset. Okay, this is a subset symbol and this one is the superset symbol. Clear the concept of superset? If A is a subset of B, then the set B is a superset of A. B is a superset of A. Let's take one example. First one, A has the elements 1, 2, 3 and set B has the elements 2, 3, 1, 4. Just observe the elements which are existing in set A and set B. 1, 2, 3. 1, 2 and 3. So all these three elements, the elements of set A is already belonging in set B. It means A is a subset of B here. Yes, A is a subset of B, but the set B has one more element, that is 4. 4 is the one more element, no, which belongs only to the set B, but it is not belonging in set A. So these type of the sets is called as a B is a superset. B is a superset for set A here. B is a superset to the set A. Clear? Take one more example. P is a set of A, B, C, D, and Q is a set of B, A, D, C, E. Just observe the elements which are existing in set P as well as in set Q. What are the elements which are there in set P and Q? A and A, B and B, C and C, D and D. So the elements of every elements of set P is belonging in set Q means P is a subset of Q. If P is a subset of Q means Q is a superset of P. If P is a subset of Q means Q is a superset of P. For every subset we can write the reciprocal of that or converse of that superset. Clear? For every subset we can write the converse. If we write the converse of that set, then that is nothing but a superset. So these are the remaining 4 types of the sets. Okay, so totally we are discussing the total types of the sets in the previous session and this session. In next session we will discuss some exercise question. Until then, be happy, have a nice day. Thank you for watching.